Hey guys, what's up? Hope you are feeling well. Today I'm going to start a second lesson that is the second lecture for the control system. Okay, we have already gone through the various topics along with the problem in the first lecture. Okay, now in this lecture series we are going to find some problem and we'll see the stability, transfer function of the electrical networks. Again, after that we'll go through the stability and finally so the problem based on the stability. Okay, we'll go through, and in this also we will see the comparison between the open loop system and closed loop system. Okay, and finally followed by the block diagram or reduction techniques. Okay, and after which we will follow through the SFG, okay, segment flow graph. Now see, there is one question. The question is on the screen. On the screen the question is available. Question which is on the screen, that find the system response if Rs is equals to 1. Okay, so the first question is find the system response for which the input signal Rs is equals to 1 and Cs equals to 1 by S plus 1 into 1 S plus 10. Okay, so for finding the system response we have to find a system response. That means if Rs system response means what is the system response for this input. We will find the effect of system when we give this Rs equals to 1 to this system. Okay, now we know that Cs response will be, we know that Cs by Rs, now basically Cs by Rs. So system response will be, SR will be Cs into 1. Okay, so partial fractions we will get A by S plus 1 plus B by S plus 10. Okay, okay, now we have to, by partial fraction we will solve for the value of A and B, and we will get that A into S plus 10 plus B of S plus 1. Okay, okay, now for finding this value it is equals to 1, so let us suppose it is 1. Okay, so 1 plus AS 1 equals to AS plus 10A plus 10 plus 10S. As value is 0, so AS plus 10S equals to 0 and A equals to minus 10. Sorry, BS is also here, na? So AS plus 10A plus, it is BS plus B. Okay, so AS plus 10A is 1. So it is AS plus 10A plus BS plus 1. This is the problem, don't worry. Equals to 1. For finding, put S equals to 0. Then 1 equals to 10A plus B. Put, for find the value of taking finite. So taking the coefficient of S, you get 0 equals to, because here is no S there, so coefficient is 0 actually. So A plus B equals to 0, where A equals to minus B. That means 1 equals to, we put this value into this, 1 10A and B equals to minus A. So 1 by 9 equals to, similarly B equals to minus 1 by 9. Okay, so the inverse of this will get Cs equals to A is what? 1 by 9 into S plus 1. Okay, minus 1 by 9 to S plus 10. Okay, now see, we will take the inverse Laplace transform. We will get inverse Laplace transform, we will get the time domain. Okay, C of t, that gives 1 by 9 exponential minus t minus 1 by 9 exponential minus 10 t. So this is the there is two terms. One is the dominant response and insignificant pole response. So it is actually dominant pole, it is insignificant pole. Okay, insignificant poles give very fast response, but in the dominant pole which lies close to imaginary axis after stability of the stability of the system. We already know that. Okay. From the previous lecture, what we have known that the insignificant pole is neglected, because even if there is no much change affecting the system response, that means what is insignificant pole? The pole which is lying in the leftmost side. The insignificant pole time constant must be less than or dominant pole, that is tau by 5. What is dominant pole? A pole which is close to the imaginary axis. So imaginary axis is the dominant pole. So this pole is very close. Okay. Now we will just take some example. Laplace of exponential of minus at equals to 1 by s plus a. Okay, and for which it will be s equals to minus a. So it is sometime like here. Okay, for this, for exponential power. Okay, for sine a or cos b t, it is b or s upon s square plus b square. For cos it is s by s square plus b square. For sine b by s square plus b square. For which it will be lies here jb minus j. Okay, will be light here, pole will be lies here. Okay, if there is something like this exponential and sinusoidal both, then of course for exponential it is real, and for this plus jb minus jb. Okay, like this. If the problem is we are getting t to the power n exponential minus 30 Laplace, we know that t to the power n is s, t to the power n is n, t to the power n is nothing but n factorial upon n plus 1. Okay, so here for dn it is nothing but n factorial upon, here for this one is n, so we write this one. Okay, this for this one, it is addition of 1. Okay, so the response consists of basically pole terms. The response mainly consists of the pole terms. Okay, the exponential power or real power of the poles. Okay, exponential power is what? The real power of the pole. It is called real power. Okay, and the sine cos function are imaginary part of the pole t in terms of the repeated or represent the repeated nature of poles. Okay, that is the repeated nature of poles. Okay, so cos functions, cos and sine function are imaginary part of pole. We are from this diagram we see it is imaginary j axis, imaginary axis of the pole, and for exponential it is the real axis, the real part of the pole. The exponential power of the real part of the pole, exponential power of the real part of the pole, and the sine cos are the imaginary part of the pole. T represent the where if t is there, then it represents the repetitive nature of pole. Okay, now we will see next question. We are getting that for the system time constant, compare Ct with exponential minus t response. That means सिस्टम टाइम कांस्टेंट के लिए क्या करना पड़ेगा, हमें ct को एक्सपोनेंशियल माइनस t बाई tau से कंपेरिजन करना पड़ेगा. मतलब पिछले प्रीवियस प्रॉब्लम में हमने देखा था, इन दिस प्रॉब्लम व्हाट वी हैव सेड दैट इट इज नथिंग बट दिस वन. So for if you want to find for system time constant will compare this one with exponential of minus t by tau c. Okay, this will compare. Now compare this one here. Tau 1 is 1. Here tau 1 is tau 1 is 1 it is 1 by 10 actually. Tau 2 is t by t, that is 0.1. Okay, it is 1. So to get the system time constant from the response, compare this response with exponential minus t by it comes with this. हम कैसे कंपेरिजन करेंगे तो देख लीजिए t यहाँ कॉमन है, पीछे कुछ नहीं है, मतलब 1 है, जाहिर सी बात है यहाँ पर 10 है. तो अगर हम एक्सपोनेंशियल माइनस 10 t लिखते हैं, इसको अगर हम कंपेरिजन करेंगे एक्सपोनेंशियल माइनस t बाई tau से, तो tau इक्वल्स टू 1 by 10, that is nothing but 0.1. Okay, so this is the answer. So to get the time constant from the response, compare the response with exponential minus t by t. System time is 1 and should be largest value instead of. Okay. Hey guys, see, we have already find the system response. Some mistake is there. We have to find the system response. Okay, we have already seen find the system response for which RS equals to 1. It is given in the previous question. So we have already calculated the time constant, and time constant tau 1 is what? How much? 1 second, and tau 2 is 0.1 second. Okay, same question we are continuing. Now we are having ct equals to 1 by 9 exponential minus t minus 1 by 9 exponential minus 10t. Okay, now this graph will be like this. To 5 tau. Okay, and this will be 1 by 9. That is what? This is for this one. So 5 into 1, 5 second actually. This is for this one. Five into 0.1, and this is 1 by 9. Okay, so if we subtract this signal, so this is 1 by 9 exponential minus t. Graph it is. And this is for 1 by 9 exponential minus 20. Okay, now on subtraction we will get somewhat like this. This is exact, but we take the approximation as this one. Okay, we take approximation and assume it is 1 by 9 and this 5 second. Okay, we are taking estimation. We are just neglecting this one. Okay, but we should not neglect this IP insignificant pole, otherwise game changes. So now we know that CS by RS equals to 1 by S plus 1 into S plus 10. Okay, we will convert it into 5 time constant. Okay, time constant for which the S plus 1, for which we will get 10 common, S plus 1 into 1 plus 0.1 plus. Okay, that means that is 0.1 for S plus 1 into 1 plus 0.1 s. Yes, whereas this is 0.1 by this one. So what we do basically, we have just neglect this one terms. As in this, we have already neglected this one. Neglect this one. Okay. Then system response will be CT will be 0.1 exponential minus of t into df. This is 1/9 exponential minus 2 into u of t. Okay. Then significant pole और neglected time constant. Okay, ये time constant के form में है. Time constant form में है actually. Time constant. है ना? Form में because system gain should not changes. System time constant के form में ही इसलिए हम इसको insignificant report है. We only just neglect this term 1 plus 0.1 s, that is the insignificant pole parts. Okay, because system gain change should not be changed. Okay. Now, next question: find the equivalent first order system. फर्स्ट ऑर्डर सिस्टम कौन सा है? थर्मोकपल जो है फर्स्ट ऑर्डर सिस्टम है. एक क्वेश्चन दिया हुआ है CS by RS बताना है. फाइंड द इक्विवेलेंट फर्स्ट ऑर्डर सिस्टम निकालना. ओके. 1 by S plus 1 S plus 10 S plus 20. सो क्या हो जाएगा? ये तो इनसिग्निफिकेंट पोल हो जाएगा, डोमिनेंट पोल होगा. ये देखने से लगा. तो T1 कितना हो जाएगा? T1 इसके लिए जाएगा कितना? तो इसको लिख सकते हैं, इसके लिए लिख सकते हैं ना -1 by -t. इसको लिख सकते हैं एक्सपोनेंशियल -10t. इसको लिख सकते हैं एक्सपोनेंशियल -20t. और कंपैरिजन करेंगे हम एक्सपोनेंशियल -t by टाउ से, तो T1 क्या होगा इसके लिए? T1 इक्वल्स टू 1 हो जाएगा. T2 इसके लिए कितना हो जाएगा? 0.1. इसके लिए T3 हो जाएगा. इसके लिए कितना? 1/20. इस 1/2 कितना होगा? 0.5. 0.05. सो ये हो जाएगा, ये हो जाएगा. ओके. ना तो इसको तो हम नेगलेक्ट कर देंगे. अच्छा, अगर हम टाइम कांस्टेंट फॉर्म में रखेंगे तो हम नेगलेक्ट कर सकते हैं. टाइम कांस्टेंट रखने के लिए क्या करना पड़ेगा हमें? तो इसके लिए क्या लेंगे? इसके लिए लेना पड़ेगा 1 by S plus 1 इंटू 10 कॉमन लेंगे, इंटू इसके लिए 20 कॉमन लेंगे. ठीक है ना? 10 कॉमन लेंगे, इसके लिए 20 कॉमन लेंगे. कॉमन में इसके लिए 20 कॉमन तो न्यू है, लेकिन वो उसके हमें क्या कॉमन लेना? इसलिए जो हम लेंगे 1/2 0.1 इंटू 1/2 0.05 ना, 0.05 by S plus 1 लेंगे. तो ये ना हमारा टाइम जो इक्विवेलेंट है फर्स्ट ऑर्डर सिस्टम को. फाइंड द इक्विवेलेंट फर्स्ट ऑर्डर सिस्टम. क्वेश्चन था फाइंड इक्विवेलेंट फर्स्ट ऑर्डर सिस्टम. एक चीज़ बताते हैं कि वाइल फाइंडिंग अप्रोक्सीमेशन सिस्टम रिस्पॉन्स, जब कभी भी हम फाइंड करते हैं सिस्टम रिस्पॉन्स बाय अप्रोक्सीमेशन, है ना, स्टेबिलिटी सिस्टम टाइम कांस्टेंट, तो ऑलवेज कंसिडर ओनली पोल्स. एक और क्वेश्चन है. क्वेश्चन है CS by RS equals to S plus 1 by S plus 2 S plus 3. इसका हमें सिस्टम रिस्पॉन्स निकालना है. इसमें देखना चेक करना. और जानते हैं सिस्टम रिस्पॉन्स इज ऑन द पोल. सिस्टम रिस्पॉन्स निकालना है, ये हमेशा पोल का निकालते हैं इसको। ओके, तो सी एस S plus 2 plus 3 by S plus 3, that is what S plus 3a plus bs plus 2b equals to S plus 1. So a plus b equals to 1, and the second one is 3a plus 2b equals to 1. तो फाइंड करेंगे और इसको मल्टीप्लाई करें 2 से, 2a प्लस 2b प्लस 2 written as minus exponential minus 2t plus 2 exponential 3. Okay, integrity. The system response only consists of time constant, number, no zero terms exist in system response. That means ये हमारा जो response कैसा रहेगा, इधर आएगा, इधर आएगा, okay, ये minus 2 में आएगा, तो ये हमारा यहाँ रहेगा, ओके। और ये नेगेटिव एक्सिस पे क्या बता रहा है, एक्सपोनेंशियली डिकेइंग होगा, ठीक है ना। ओके, अब हमें फाइंड करना है e ऑफ माइनस टी से, इसे कंपेयर कर, जिससे कंपेयर करेंगे तो क्या होगा, t1 इक्वल्स टू, कंपेरिजन तो करना पड़ेगा इसको t1, तो कंपेयर करेंगे अगर हम t1 से, तो इक्वल्स टू 1/2 इज 0.5, 2t इज नथिंग बट 1/3, 0.33, it is so much. Okay. हम डायरेक्ट निकाल सकते हैं, सारे कितने 0.5 है, 0.3, तो वो चीज़ very close to 0.5, तो मान लो क्या करते हैं, क्वेश्चन में इसके सीक्वेंस में करेंगे तो सी उसमें बोला जाता है कि बाय फाइंडिंग एप्रोक्सीमेशन सिस्टम रिस्पॉन्स सिस्टम स्टेबिलिटी सिस्टम टाइम कांस्टेंट, जब कभी भी हम एप्रोक्सीमेशन करते हैं चाहे सिस्टम रिस्पॉन्स के चाहे सिस्टम स्टेबिलिटी के लिए चाहे सिस्टम टाइम कांस्टेंट के लिए, always consider poles but not zero because the system response consists only pole and terms there is no any zero exist. Okay. So for finding stability, for finding system response, finding system time constant, consider only pole. Okay, because not the zero. Because the system response can consist only poles, terms, no zero terms in the response. Okay. Now see the transfer function of an electrical signal. Okay. This is the transfer function of an electrical network. और कुछ सिग्नल दिया हुआ है और अगर गेट वन सिस्टम्स यहाँ पे कुछ गेट it is like this, and V1 is the input, V2 is the output. Okay, here then V0 as by the input is nothing but impedance across output. Impedance across output upon total circuit impedance. ये फाइंड करना रहेगा इस टाइप का नेटवर्क्स के लिए हम ऐसे ही करेंगे V0 बाय गेट टू एस impedance across output get to s on total circuit get on as get to s. Okay, now we'll solve the question taking a rest.